Hello students, welcome to chemistry class. In the last class we have studied about the chemical equations and stoichiometric calculations, and also we have studied about the what is meant by limiting reagent and some problems on the stoichiometric calculations. So in this class let us continue the discussion of the problems based on the stoichiometric calculations. In that first one, that is how much copper can be obtained from 100 grams of copper sulfate. So we have 100 grams of copper sulfate. In that we have to calculate how much copper is to be obtained. So first we have to calculate what is the molar mass of copper sulfate. That is molar mass of copper sulfate, CuSO4. So molar mass is always equal to the sum of the atomic masses of all the elements present in the molecule. That is sum of the atomic masses of elements, that is copper plus atomic mass of sulfur plus 4 into atomic mass of oxygen. So atomic mass of copper is 63.54 and atomic mass of sulfur is 32.06 plus 4 into atomic mass of oxygen, so it is 60. So that is equal to 159.6 grams per mole. So that is the unit for the molar mass is grams per mole. According to stoichiometric calculations, that is 159.6 grams of copper sulfate, CuSO4, contains 63.54 grams of copper, right? So the 63.54 is the atomic mass of copper. So 159.6 grams of copper sulfate contains just 63.54 grams of copper. So they have asked about how much amount of copper is to be present in the 100 grams of copper sulfate. That is 100 grams of copper sulfate contains X grams of copper. That is X is equal to, so 100 grams into 63.54 divided by 159.6, that is X is equal to 100 grams of copper sulfate into 63.54 divided by 159.6. So on simplification it gives 39.81 grams of copper. That means the standard statement, that is molecular mass of the copper sulfate is 159.6. So this 159.6 grams of copper sulfate contains 63.54 grams of copper. And in the case of 100 grams of copper sulfate contains 39.81 grams of copper. So this problem is based on the how much amount of that element present in the given mass of the compound. Next, let us see one more problem. That is, in 3 moles of ethane, calculate the following. So in 3 moles of ethane, so ethane formula is C2H6. So in that first problem, so we have to calculate the number of moles of carbon atoms. So how many moles of carbon atoms present in the 3 moles of ethane? So solution, that is write the standard statement. So 1 mole of ethane, C2H6, contains how many carbon atoms? 2 carbon atoms. So it is a standard statement. So 1 mole of ethane contains 2 carbon atoms, or it is to be represented as 2 moles of carbon atoms. So 1 mole of ethane contains 2 moles of carbon atoms, and therefore number of moles of carbon atoms in 3 moles. That is, 1 mole contains 1 mole of C2H6 contains 2 moles of carbon atoms. 3 moles of C2H6 contains X moles of carbon atoms. So X is equal to 3 into 2 divided by 1, that is equals to 6 moles of carbon atoms. So very simple problem. So in the 1 mole of ethane, it contains just 2 moles of carbon. So in the formula, it contains 2 carbon atoms. So 1 mole of this molecule contains 2 moles of carbon atoms and 6 moles of hydrogen atoms. But in the problem, they have asked only about the carbon atoms, right? So 1 mole of ethane contains 2 moles of carbon atoms, but the 3 moles of ethane contains 6 moles of carbon atoms. And in that next problem, that is number of moles of hydrogen atoms. So very simple problem. That is 1 mole of C2H6 contains 6 moles of hydrogen atoms, because the formula for the ethane is C2H6, so it contains 6 hydrogen atoms. Therefore the 3 moles of C2H6 contains X moles of hydrogen atoms. That is, X is equal to 3 into 6 divided by 1. That is 6 3s are 18 moles. 18 moles of hydrogen atoms. That is, 1 mole of ethane contains 6 moles of hydrogen atoms. So the 3 moles of ethane contains 18 moles of hydrogen atoms. So very simple problem. So this 1 mole of ethane contains 2 moles of carbons and 6 moles of hydrogen atoms. And in the 3 moles of ethane contains 6 moles of carbon atoms and 18 moles of hydrogen atoms. And next problem in the same question, that is, we have to calculate the number of molecules of ethane. So we have to calculate how many molecules of ethane present in the 3 moles of the ethane. So first to write the standard statement, that is 1 mole of any compound, that is 1 mole of C2H6 contains Avogadro number of molecules. So Avogadro number is 6.022 into 10 to the power 23 molecules. That is molecules of C2H6, right? So the 3 moles of C2H6 contains X molecules of C2H6. So writing of this standard statement is very important, right? So 1 mole of ethane contains the 6 Avogadro number of, or 6.022 into 10 to the power 23 molecules of ethane. So in the problem they have asked about calculate the number of molecules of ethane in the 3 moles of ethane. So X is equal to 3 into 6.022 into 10 to the power 23 divided by 1. So that is equal to 3 into 6.022 into 10 to the power 23, that is equal to 1.8066 into 10 to the power 24 molecules, that is molecules of C2H6. That is, in this problem we have learnt about the how to calculate the number of molecules present in the desired moles of compound, right? And let us see one more problem, that is calculate the number of atoms in each of the following. So in this problem we have to calculate how many atoms are present in the 52 moles of argon. So Ar is nothing but argon. So write this standard statement, that is 1 mole of argon, 1 mole of Ar contains Avogadro number of atoms, that is 6.022 into 10 to the power 23 atoms. So first we have to write this standard statement for the 1 mole of argon. So 1 mole of argon contains Avogadro number of atoms. So we have to calculate how many atoms are there in the 52 moles of argon. So 52 moles of argon contains X atoms, that is X atoms of argon, and it is also X atoms of argon. So X is equal to 52 into 6.022 into 10 to the power 23 divided by 1. So that is equal to 3.13 into 10 to the power 25 atoms, that is atoms of argon. So 1 mole of argon contains Avogadro number of atoms. So 52 moles of argon contains 3.13 into 10 to the power 25 atoms of argon. And next we have to calculate how many helium atoms are present in the 52U. So U is nothing but unified mass, right? So write the standard statement based on it, that is atomic mass of helium, that is helium atomic mass is 4U, right? So 4U of helium is equal to 1 atom. So 1 atom of helium has 4 unified mass. So 52U of helium contains X atoms, right? So that is X is equal to 52 into 1 divided by 4. So on simplification it gives 13 atoms. So 4U of helium contains 1 atom and 52U of helium contains 13 atoms. And next let us see about how many atoms are there in the 52 grams of helium. That is, the atomic mass of helium is 4 grams, right? So atomic mass of helium is equal to 4, that is to be expressed in the grams. that is 4 grams of helium contains 6.022 into 10 to the power 23 atoms of helium. So we have to calculate how many atoms are there in the 52 grams of helium. So 52 grams of helium contains X atoms of helium. So X is equal to 52 into 6.022 into 10 to the power 23 divided by 4. That is, on simplification, it gives 7.83 into 10 to the power 24 atoms. Right? So the difference between the previous problem and in this problem is, in the previous problem it is to be explained in terms of U, unified mass. So 4U is nothing but one atom. So 52U contains, or it means 13 atoms. Like that, if it is to be expressed in the grams, that is 4 grams of helium contains Avogadro number of atoms. So atomic mass of helium is 4 grams. So gram atomic mass of that element contains Avogadro number of atoms. So 52 grams of helium contains X atoms. So X value is 7.83 into 10 to the power 24 atoms. And next, let us take one more problem, that is calculate the number of moles in each of the following. That is 7.85 grams of iron. So let us see how to solve how to calculate the number of moles present in the 7.85 grams of iron. So first let us take the formula, that is number of moles always to be calculated by using the formula, that is moles of iron is equal to mass of iron divided by molar mass of iron. That is, mass of iron is 7.85 grams divided by, so the atomic mass of the iron, so it is an atom, right? So in the formula just write atomic mass. So atomic mass of iron is 55.8 grams per mole. So grams and grams to be cancelled, that is, on simplification it gives 0.141, and 1 divided by per mole is to be written as mole. And next let us calculate the number of moles in the 4.68 milligrams of silicon. So 4.68 milligrams of silicon. So moles of silicon is equal to mass of silicon divided by atomic mass of silicon. So atomic mass of silicon, so that is equal to mass of silicon is 4.68 and it is in the milligrams, so convert it into grams, that is into 10 to the power minus 3 grams divided by atomic mass of silicon is 28.1 grams per mole. So on simplification it gives 1.67 into 10 to the power minus 4 moles, right? So then moles of silicon is 1.67 into 10 to the power minus 4. Like that, let us calculate the number of moles present in the 65.6 mu grams of carbon. That is, moles of carbon, that is equal to mass of carbon divided by atomic mass of carbon, that is 65.6. Mu value is into 10 to the power minus 6 grams, and it is divided by atomic mass of carbon, so it is 12. So on simplification, that is 12 grams per mole. So grams to be cancelled. So on simplification, it gives 5.47 into 10 to the power minus 6 moles. That is 7.85 grams of iron contains 0.141 moles of iron, and 4.68 milligrams of silicon contains 1.67 into 10 to the power minus 4 moles, and 65.6 mu grams of carbon contains 5.47 into 10 to the power minus 6 moles. So this is the method used to calculate the number of moles of the element if they have given the atomic masses of the elements. And next, let us see one more problem, that is the calculate the number of moles in each of the following masses. That is 1.46 metric ton of aluminum. So we all well know that 1 metric ton is equal to 10 to the power 3 kilograms, or that is equal to 10 to the power 3 into 10 to the power 3 grams, right? So let us see how to solve this problem. That is 1.46 metric ton of aluminum is equal to 1.46 into 10 to the power 3 into 10 to the power 3 grams of aluminum. So that is equal to 1.46 into 10 to the power 6. So 3 plus 3 is 10 to the power 6 grams of aluminum, right? So atomic mass of aluminum is 27. That is atomic mass of aluminum is equal to 27. So moles of aluminum, so we have to calculate the number of moles. So moles of aluminum is always equal to atomic mass of aluminum, atomic mass, sorry, not it is atomic mass, so it is mass of aluminum divided by atomic mass of aluminum. So mass of aluminum is 1.46 into 10 to the power 6 grams divided by atomic mass is, that is 27 grams per mole. So on simplification, it gives 5.41 into 10 to the power 4 moles, right? So 1.46 metric ton of aluminum contains 5.41 into 10 to the power 4 moles of aluminum. And next, let us see how to calculate the number of moles in the 7.9 milligrams of calcium. Very simple problem. So first we have to convert this milligrams into grams. So that value is equal to 7.9 into 10 to the power minus 3, that is milli value is 10 to the power minus 3 grams of calcium, right? So the atomic mass, of calcium is equal to 40.1. So moles of calcium is equal to mass of calcium divided by atomic mass. So mass of calcium is 7.9 into 10 to the power minus 3 grams divided by atomic mass is 40.1 grams per mole. So on simplification, it gives 1.97 into 10 to the power minus 4 moles, right? So this is the method to calculate the number of moles in the given mass of the elements. And next problem, that is, which one of the following will have the largest number of atoms? So it is MCQ question that is to be asked in the competitive exams. That is, we have to calculate which one of the following will have the largest number of atoms. First one, 1 gram of gold, that is in the solid state, and second one, 1 gram of sodium, and third option is 1 gram of lithium, and fourth option is 1 gram of chlorine molecule, that is in the gaseous state. Let us see how to solve the atomic mass of the following options. First one, that is 1 gram of gold, right? So the atomic mass of gold, atomic mass of AU, that is equal to 197 grams per mole. So 197 grams of AU contains Avogadro number of atoms, 6.022 into 10 to the power 23 atoms. So we have to calculate how many atoms are there in the 1 gram of AU, that is X atoms, right? So X is equal to 1 into 6.022 into 10 to the power 23 divided by 197. So on simplification it gives 3.057 into 10 to the power 21 atoms. And let us calculate the number of atoms in the 1 gram of sodium. That is, 1 gram of sodium is equal 1 into 6.022 into 10 to the power 23 divided by the atomic mass of sodium is 23. So on simplification it gives 2.6 into 10 to the power 22 atoms. Like that. Third one, that is 1 gram of lithium. So 1 gram of lithium is equal to 1 into 6.022 into 10 to the power 23 divided by the atomic mass of lithium is 7. So on simplification it gives 8.60 into 10 to the power 22 atoms. Like that, let us calculate the number of atoms in the 1 gram of chlorine, Cl2. That is, the molecular mass of chlorine molecule is 71. That is equal to 1 gram into 6.022 into 10 to the power 23 divided by the molecular mass of chlorine is 71. So on simplification it gives 8.48 into 10 to the power 21 atoms. So which option is correct? That is, gold contains 3.057 into 10 to the power 21 atoms, and this sodium contains 2.6 into 10 to the power 22 atoms, and this lithium contains 8.6 into 10 to the power 22 atoms, and this 1 gram of chlorine contains 8.48 into 10 to the power 21 atoms. That is, the correct option is 1 gram of lithium, right? So this 1 gram of lithium contains 8.60 into 10 to the power 22 atoms.